Torque on the dipole in uniform electric field. Now the most important topic, how to find torque or couple acting on electric dipole when placed in uniform electric field. It can be inquired like this, or prove that torque vector equals P vector cross E vector. So this is derivation. How to have notes, how to write in examination. See this. This is theory of the derivation. First of all, consider an electric dipole minus q plus q separated by distance 2a, placed at an angle of theta in uniform electric field. Whatever you consider, whatever your requirement, write this. This is point number 1, theory of the derivation. इसमें हमने माना एक डाइपोल है जिसमें चार्जेस कुछ दूरी से सेपरेटेड है, यूनिफॉर्म फील्ड में एट एन एंगल थीटा हमने उसे रखा है. Now this dipole having its strength, its quality, dipole moment. Dipole moment is the magnitude of either charge multiplied by distance between two charges. तो mod of either charge q और उनके बीच का डिस्टेंस 2a. So q into 2a is dipole moment. Equation number 1. Now you know any charge when placed in electric field, it will experience force. Electrostatic Lorentz force. You may write it from electrostatic Lorentz force. As per electrostatic Lorentz force equation, force experienced by plus q charge as well as minus q charge. So first of all, force experienced by plus q. Let us say it is F1 vector. So force on this will be plus q into E. Electric field is uniform. Everywhere in the region it is constant in magnitude and direction. मतलब जो field यहाँ है वो हर जगह है. That is called uniform. So force experienced by minus q, it will be F2 vector minus QE. You know the significance of plus sign. Plus sign means field and force, they are in same direction. So plus q charge के ऊपर same direction में force लगेगा as that of electric field. Minus sign signifies F2 vector is in opposite direction of electric field. Electric field right side में है. Then force 2 will be acting in opposite direction on the left hand side. These two forces are opposite in direction. One in the same direction of field, another opposite to that. Take magnitude. Mod of F1 vector, it is QE. Mod of F2 vector, again it is QE. This dipole under action of two forces which are equal and opposite, so net force on the dipole will be 0. This is separate question which is inquired. Prove that no translatory force acts on the dipole in uniform electric field. तो आपको लिखना होगा 1, 2, 3, 4. You may write the same point like this also. Point number 4. Net force acting on the dipole in uniform electric field is 0. Why? One reason is this. Since two equal and opposite forces are acting on the dipole in uniform field, so it is 0. Why equal opposite? See, their magnitudes are equal, direction opposite. So you may write like this, or you may write in vector form. But remember, vector form should be obeyed with vector notation. Net force on the dipole vector equals F1 vector plus F2 vector. It is plus QE vector, it is minus QE vector. They are equal and opposite vectors, they are cancelling. So net force on the dipole in uniform field will be 0. Next, step number 5. Now you want to find torque or couple. When net force on the dipole is 0, then couple or torque comes into play. How to find this torque? There are 3 ways. First of all, what is torque? Previous revision. Torque vector is R vector cross F vector. It is RF sin theta. You may find it like this. Or when theta is 90 degrees, sin 90 will be 1. So torque will be RF. You may write R into perpendicular force, or you may write force into perpendicular distance. So we will follow this. Torque is force into perpendicular distance. मतलब आप force कोई भी ले लें, perpendicular distance को उससे multiply करना है. Perpendicular distance to that force. Vice versa. आप ऐसा भी कर सकते हैं, आप परपेंडिकुलर फोर्स ले लें, दूरी फिक्स कर दें, या आप सीधा ही फॉर्मूला लगाएं आर एफ साइन थीटा. सो बेस्ट इज टेक वन फोर्स एंड फाइंड perpendicular distance of that force. See this in this experiment, in this derivation. Let us say we take F1. Now you take either of force, or you may take both the forces as well for finding torque. Like we are taking F1. Abhi you will have to search for perpendicular distance. See by construction. Let us say it is A, it is B. And notice this perpendicular distance A to N. This A to N by construction, it is visible, it is perpendicular to F1. So you may take any force, but you will have to multiply by perpendicular distance. It is A into N. तो यहां आपको लिखना होगा A into N. Now what is F1? From second equation, F1, F2 both having same magnitude, Q into E. So F1 is Q into E. What is AN? This AN is this one. From this triangle you may find it is 2a sin theta. Now you may write it like this. First of all write this is 2a, this is 2a sin theta, with the reason. Because in this triangle ABN, see this is perpendicular, this is theta, this is also theta. 90 और एंगल को मिलाने वाला लाइन BN, it is base, it is perpendicular. So perpendicular upon hypotenuse, find sin theta. Perpendicular AN upon hypotenuse 2a. So you see AN is 2a sin theta. So in place of AN we have written 2a sin theta. Now with reference to first equation, dipole moment is Q into 2a. In place of Q into 2a, you can write P, dipole moment magnitude. So this will become torque is equal to P, remaining part E, into sin theta. This is called, in vector notation, torque vector is P vector cross E vector. This is the torque or couple experienced by dipole in uniform electric field. Now see the concept part, most important again. Torque vector is P vector cross E vector. It can be written in magnitude like this, PE sin theta. Now the most important point, what is theta? Theta is the angle between those two vectors जिनके बीच में डॉट या क्रॉस प्रोडक्ट है. So theta is the angle between P vector and E vector. And the most important point, when they are joined from head to head or tail to tail. What? See this. For example, this is P vector and this is E vector. This is 60. See, this is P vector, this is E vector. Again it is 60. Seems to be the same answer, but both are different. In first, both vectors P vector and E vector joined from tail to tail. So this is called theta directly. Theta is 60. In this, tail of P vector joined with head of E vector. Head mane arrow. So you may replace, you may displace vector anywhere in the space, keeping same magnitude and same direction. हमने इस E vector को थोड़ा आगे displace किया, same magnitude, same direction रखते हुए. Now both are joined from tail to tail. P vector, E vector joined from tail to tail. This is called theta. So which is total 180 degrees minus 60 degrees. This is 120 degrees. See this point in the point of dipole. Point number 2. In the derivation, plus q was here and minus q here. This was defined as theta. This is one numerical. Another, see this. Third point. This is minus q, this is plus q. Now it is 60. Okay, we deal with numerical. It is 60, it is 60 again. Now you must remember what is the direction of p vector. Again, p vector, direction of p vector is from minus q to plus q. So here are 3 points. First point, direction of p vector from minus q to plus q. Minus q to plus q. This is p vector. माइनस q यहां ऊपर की तरफ है, तो माइनस q to plus q. This is p vector. Second point is E vector. E vector given from left to right. E vector is given from left to right. Now third point is theta. When they are joined from tail to tail. Now see, they are joined from tail to tail. This is theta. This angle. This whole angle is theta. 60 degrees. Now they are joined from tail to tail here. This is theta. This will be 180 minus 60, 120 degrees. For numericals, you will have to focus where plus q charge is placed. Like derivation here or here. That will change the direction of p vector, because p vector is from minus q to plus q. So this is numerical concept. Now see, again most important 3 points. This is the direction of uniform electric field. Now dipole is placed in 3 different ways. Minus q, plus q. Focus, कहाँ रखा है plus q, कहाँ रखा है minus q. This is minus q, this is plus q. Point number 1, p vector की direction है minus q to plus q. Here minus q on the right hand side. Minus q to plus q, this is p vector. Minus q to plus q, this is p vector. Electric field direction, left to right in all the 3 cases. In the first, p vector and e vector both are in same directions. So theta will be 0 degrees. Theta is the angle between p vector and e vector when joined from tail to tail. Now p vector, e vector in opposite direction. So theta will be 180 degrees. P vector is perpendicular to e vector. So theta will be 90. Now torque. Torque is Pe sin theta. Here theta is 0. So torque is 0. Theta is 180. Torque is Pe sin 180. So sin 180 will be 0. Again torque is 0. Theta is 90. So torque is Pe sin 90. Sin 90 is the maximum value. 1. So it is Pe. This is the maximum value of torque experienced by the dipole. Once again breathe in. Now there are so many questions based on this. See, torque is 0. In both cases, first and second, net force on the dipole is 0. Even all the 3 cases, net force is 0. Dipole को आप किसी भी पोजीशन में रखें, dipole के ऊपर net force तो 0 लगेगा. In uniform field, it is uniform electric field. Now torque is 0 in first and second point. These 2 points represent equilibrium. This is equilibrium. This is also equilibrium. Torque भी 0 है. Net force तो है ही 0. Now dipole is not experiencing any force, any torque. So this is the position of equilibrium, as well as this is the position of equilibrium. Now this is called stable equilibrium and this is called unstable equilibrium. In your examination, it is inquired which type of equilibrium? Unstable equilibrium. Unstable equilibrium means on disturbing this, it will never come back in the original position. Stable equilibrium means on disturbing this, it will come back. See this. Shift dipole anti-clockwise. When you shift this dipole anti-clockwise, situation will be like this. This dipole will be in this orientation, plus q minus q at an angle theta. Now, on disturbing this dipole from its original configuration, what is going to happen? It will experience two equal and opposite forces. Net force will be 0. It will experience torque. Now, what is the effect of torque? This torque aligns या rotates the dipole in the same direction of electric field. See this. This rotation will be like this. आप खुद इमेजिनेशन करके देखें, यहां से एक फोर्स लगे, एक फोर्स इधर से लगे. I'm pushing this F2 force from my fingers. See this, it is rotating like this. It is rotating clockwise and it is acquiring same 0 degree orientation. On disturbing, it is acquiring same position again called stable equilibrium. So remember, in examination they are going to inquire which type of equilibrium. It is stable equilibrium. They may ask reverse. Draw the diagram when dipole placed in uniform field for stable equilibrium position. So you will have to draw this diagram for the angle 0 degree. Find the next question, at what orientation 0 torque, no torque experienced by the dipole. So answer is 0 degree as well as 180 degrees. In both the orientation, torque is 0. He may ask at what orientation or at what angle maximum torque experienced by the dipole. 90 degrees. Make the diagram. You will have to make this diagram. He may ask anything. See this, I am writing one question. At what orientation or angle dipole experience maximum torque in uniform electric field? तो आपको बताना at an angle 90 degree. He may say make the diagram. Similarly, he may ask, this is separate point, point number 4, as well as it is linked with point number 1. See point number 5. At what angle torque is half of max torque when dipole placed in uniform electric field? See the question. Answer. Torque is half of max torque. Half of max. So at any instant torque called Pe sin theta. Maximum torque is P into E. You will have to remember what is the maximum torque experienced by the dipole. Now simplify. P cancels, sin theta is 1 by 2. Ordinarily we write 30 degrees. As well as you may write in the principal value is 120 degrees. This is 30 degrees. You write 30 degrees. एक और लंबी गहरी सांस लें. Now see numerical. One dipole of charges plus minus 2 microcoulomb separated by 4 centimeter placed in uniform electric field of 100 Newton per coulomb. Find net force experienced by the dipole. Ordinarily, student says this or that. But focus, it is net force. No net force. Net force is 0. Net force on the dipole in uniform electric field is 0. As equal and opposite forces are acting on dipole in uniform electric field. This is uniform electric field. This is dipole. Plus q minus q placed at arbitrary angle theta. On plus q force is F1 plus q into E. On minus q it is F2 minus q into E. They are equal and opposite. Net force will become 0. But if he says find torque, then it is separate question. Then you will have to write torque is PE sine theta. You know how to find P? Mod of charge into distance, electric field given. This angle will be given. If he is asking torque, then he will say like this: find torque when dipole placed at an angle theta, placed at an angle of 60 degrees. Then theta is given. Input the values. Units of torque should be written as Newton meter, because torque is force into perpendicular distance. So units will become Newton into meter. But the most important question, if he says find maximum torque, then you have to apply your mind. Maximum torque happens at an angle of 90 degrees. So maximum torque ke liye he will not give you this angle or another angle. He will just say find max torque. So you will have to remember it happens at an angle of 90 degrees. It is PE. Now simplify again, units Newton meter. एक लंबी गहरी सांस लें.